So we got these two functions, and what they're going to ask us to do is they're going to ask us to add these two functions together. So if I had a problem like this, if I had m of x, which is going to be my new, this is my new function, okay? And they want me to make m of x by adding f of x and g of x together. If they gave it to me as an equation, meaning they say, hey, f of x really equals x plus 2. G of x really equals 3x minus 1. If I want to figure out actually what m of x is, what could I do right here? Yeah, so it sounds like the same thing here. You can take out this, put what it equals in, so you can put in x plus 2. Is everybody okay with that? And then what you can do is you can add 3x minus 1. Then together, we can see that x and x are going to add together, so you get 4 x's. You have 1x plus 3 more x's, you have 4 x's. Some of you are still working on trying to even just have 1x. And 2 minus 1 is going to be a positive 1. So that would be what m of x is. Is everybody okay with that? When I started out, what kind of function was f of x? What is x to the power of? So what does that make it? Makes it linear, right? What was g of x? What's x to the power of? So it makes it a linear. Makes it a line, right? And what is this one going to be? Well, look right here. X is still to the power of, so it's still going to be linear. Notice when we added the functions together, it didn't change the shape of the graph. Everybody okay with that? Now let's go back to what they have in us do. They're going to give us something like this instead. And here they're going, hey, here I gave you the functions, right? Here, what are they giving you? They're giving you the graphs. They're not giving you exactly. They're not giving you the function. They're just giving you the graph. And I want you to give me the new graph, which is going to be m at x. I need to, that's what they're going to say. I want you to make m of x by adding f of x and g of x together. Are you with me? So, if I'm going to make m of x, I'm going to take f of x and g of x and add together. Try to write this. No, I'm going to go to m of x, and it equals f of x plus g of x. Now, what does this really stand for? What did we say yesterday? It stands for, it's really just a y. Yes, it is. It means that it's a function, but it's the y. Now, the only thing is, it's the y value of the f line at x. When you're on a coordinate plane, what do you need? If I want to go to a certain point, what do you need? Yeah. What do we call those? Coordinates, order pairs, an x and a. So I need an x and a y. When I put this right here, I'm saying for this equation, I'm giving you the x value of this, right? I'm giving you the what? X value. And right here, I gave you the what? And if it's 6 here, what does it have to be here? And what does it have to be here? And what I need you to find is, when I tell you it's 6, are you ladies with me? When I tell you x is 6, I want you to figure out what's the y value from here. And that's what's going to go in this place. But it's of the f line. When I say g of x, you're going to do the same thing. It's going to be the y value, but of the g line. So here's what it means. Let's go back. Let's say I want to find m at 6. What is that going to equal? F at plus, and what am I looking for? This is going to be the y value when x is 6 of the f function. And I'll put that right here in its place. And I'm looking for the y value of the g function when x is 6, and I'm going to put that here. So what value am I looking for both times? The y. Does everybody see over here on my graph, this line right here is where x equals 6. Every time I'm on that line, my x is 6. Right here, what's the ordered pair? 6, 8. What's the x value? 6. What's my ordered pair here? 6, 6. What's still my x value? 6. When I go here, what's my ordered pairs? 6, comma, negative 8. What is changing every time I go up and down that line? The y. Are you with me? So I want, when I'm on the f line, and my x is 6, I want to know what's the y value. Well, let's go over here. Does everybody see this is the f graph? So I go along, I go along, I go along, boom. That's where my x is 6. What's my y value if I'm on that line? And so that's going to be the replacement that I put in here, because that does stand for the y that's there. Does that make sense? Plus g at 6. Go ahead and try that on your own real quick. G at 6. What would be the replacement that would go into that? Everybody got an answer? He says it's negative 2. So we go over and we say, okay, 6, if I'm on this line, it would be negative 2. And when I add those together, what do I get? 2. What does that mean for my new line, which I'm trying to make, which is the m line? It means what would be my first ordered pair that I could graph? 6, because that's the x value. And what's the y when I'm at 6? 2. Do you understand how we come up with this? And so I go 6, and I'm going to do it in blue for you. 6, comma 2. I love it. That's red. Orange or blue will never be up there.
Here's an orange. It looks orange.
No, that's red. Orange and blue suck.
It looks orange in there.
We'll see.
Very orange. Yeah.
Very suck. Alright. Got football season coming up. Don't worry. You guys will lose the first couple games and then we'll... I know. Alright, Tebow's not there anymore, okay? Your reign is done. Alright. So, if we have this, how many points from geometry, how many points do you need to make a line? 2 points. Now, my son is this type of child, okay? Because he's done it to me, and he's getting worse and worse about it, so I'm having to try to put him in his place without trying to beat him. So what I do is, he'll go like this. I'll say, you have 2 points, and between 2 points, there's only one line. He'll go, well, Dad, let me show you something. And I'm like, Kai, you're wrong. Dad, watch. If you do something like this. There's point 1, right, Dad? Okay, yes, Kai. Here's point 2. Look, there's one line, There's 2 lines. There's 3 lines. There's 4 lines. Yeah, there's a whole bunch of lines that could go through those 2 points. And then in first period, I had a kid go, yeah, that's what I was thinking too. Okay. So, what happens? What happens is, what's wrong with this? What's the definition of a point? That sounds good. That's what I'm going to go. It only holds one thing. You're okay. What's the definition of a point? But what's the definition of a point? Point has no dimension. Has no size. Technically, I shouldn't even be able to draw a point, but it doesn't look good when I go, hey, look at the point. I need to go, look at that point. So I give it some time, but technically, doesn't that have size and dimension? But without that, you guys went, yeah. You wouldn't be able to see it. So we draw those on there like that, and then between those two, we show you that there's only one line that connects the two. What's the problem with my son's 2 points? They have size. They have a freaking area. They're circles. They're not points. Okay? So between 2 points, there's only one line that's going to connect them. That's from geometry. Well, we're going to use that here because if I know that that's 1 point, all I need to do is get what? All I need to do is get what? Okay. You know, it's interesting, Janice, we're walking. All I need is what up here now? I have 1 point. How many do I need? 2. So I got to do this again. And once I get the second point, then I can draw a line in it because there's only going to be, I only need me to do this twice. That would be end line. Okay. Now, notice the point that I picked. I didn't think through it. I just picked 6 and just went with it. There's actually a couple numbers up here that would actually even be easier. Because I'm adding the y's together. Look at that. If I'm adding the 2 y's together. You see how I had 4 and I added a -2? I'm telling you right now, there's kids that mess that up. Because you got a positive and you got a negative, and they freak out when they see that stuff. So if I'm choosing this, don't I get to pick the easiest route? Do I have to pick, how many points do I need? 2. So can I just pick the 2 easiest ones? So can someone look up here and say, what would be an easy point to pick? X, if X was this, it would be really easy to add together because of their Y's. I need a reason why. It says 2. Oh, okay, 2 plus 2 is 4. That's not too hard. It's even easier than that. 0 I can do, that's just 1 and 4. There's even easier than that. Because I'm getting 2 numbers. Why'd you say -2, Perry? The line is on the what? X-axis. What is my y value right there? What is my y value right there? 0. So I'm going to add, remember these were both my y's. I'm adding the y's together, right? To get this. So I'm going to add 0 plus 6. What's 0 plus 6? Isn't that easier than anything else that we've set up here? Right? So, not that the other ones were really hard, but my other problems might have more difficult numbers. Are you following me? So if I just do that, boom. Someone else find another really easy number that I should have used. Remember, I only needed 2. So technically, I have my line and I'm done. But just for fun, because math is so much fun. Someone else besides Perry. I think he sees it. Yes. 4. Because if you look at 4, what is the y value on this line right here? It would be what? 0. And I would do 0 plus 3 would be what? 3. See if we got this. I want you to find m at, let's go with -4. negative 4. This is going to be my line where x is negative 4. So you're going to be looking for those y values where it intersects that green line. And you need what? Alright, here we go. If we have this one, what is this would be f at negative 4, and I'm going to add g at negative 4. Here, let's do that. It's alright. Okay. That's suave up here now. There we go. Oh my god! This thing is going. As soon as it gets right to it. Okay. So it should be negative 4 there. So what's my y value when I'm on that line, the f line, and I'm at negative 4? So f, this is the f right here. And where is it at negative 4? It's at negative 1. So you should put a negative 1 plus, go in your g, sit right there, which is 8 is the y value, and that should be 7. Now let's look. What would be my ordered pair then? Negative 4, 7, right? And so I go negative 4, 7. Is that an ordered pair? Or right here, 7, sorry. Is that an ordered pair on that blue line that I created? Yes. Kind of makes sense. Questions? Yes.
So it doesn't matter with the negative 1 to 8 in order, like, 7 of 8.
Not for this one. Here's the reason why, Perry. That's a very good question. What Perry is asking, we're going to get to in just a minute. Perry said, well, does it matter if I did the order wrong? And maybe I did it wrong. Because you have right here the function. What do we know about addition? Doesn't matter which order. Now, let's say they had asked me to subtract these, and you would put the reverse order of that. Would that have mattered in your answer? 100%. So that's where you have to be careful. We're actually going to talk about that in just a second. So if it's addition, you got lucky and be fine. But if it's subtraction, you need to make sure you put the f of x first and then the g of x, because it does. One will be negative if you have one way, probably one will be positive if you have the other way. With me? Okay. Good question. Very good question. All right. All right, commutative property. So commutative property says this. 2 plus 3 equals 5. Yes? And 3 plus 2 equals. Now, what did we just discuss? Is subtraction commutative? 3 minus 2 is? 2 minus 3 is? So are these the same? So it's not commutative. However, be careful when you say that, because subtraction is not commutative in and of itself or by itself. But hopefully you learned something in middle school, that your teacher said something like this. Subtraction is the same thing as adding a what? The same thing as adding a negative. Now, why does Mr. Martin point this out? It's because now what did I make subtraction? Which is now what? Commutative. So technically, is subtraction commutative in and of itself? No, it's not. But is there a way around that? And will we be using that throughout this year? Yes. So you've got to remember that subtraction and adding a negative are the same types of things. And that's a way around to make subtraction commutative. Okay? That's what we're talking about, how you're going to have the little skills from over in middle school. I'm going to refer to them all the time. And we're going to be using them throughout a lot of problems. And I'll show you how they're actually useful. All right, what about this? What's 2 times 3? And what's 3 times 2? Therefore, multiplication is also what? Commutative. Is division. Oh, not in and of itself. Okay, well, what you got? Tell me how to do it then.
Well, maybe you could do it like the subtraction.
So you start off all confident, like, you can do it, and you were actually right.
But I wasn't.
You were right.
Oh, I was right.
You were right, but then you got all scared. Like,
I was right.
Yeah.
Oh.
So division in and of itself is not commutative because 2 divided by 4, please, I had a kid who said that can't be done. Yes, it can. It's called a fraction. It's called 1/2. Can't divide by 0. It's an undiscriminate form, or it's undefined, but there's actually, later on, people study all that kind of stuff. Yeah. So here's what happens. With this right here, when we have this and we want to make it commutative, let's go to something completely different for just 1 second. What happened when a teacher put this on the board? Because it's so crazy that we don't connect these two. I don't know why in middle school we never connected these, but I wish we would. What happened when you had this? Do you divide fractions? You do what? What did your teacher maybe tell you? Something like keep, change, flip, or some kind of... And what are you doing? You're taking this. What does this mean? What do you mean change? What does that mean? Changing it to what? Multiplication. When you change it to multiplication, what is it now? Commutative. So what happens here is we can make it like that, right? So how does that work for this problem over here where we have 4 divided by 2? Because I show you that in fractions because that's where we really teach it. But it still works in whole numbers because I can make a whole number of what? Make a whole number of fraction. Just put this over 1, put it over 1. So this would become 4 over 1 what? Times 1 over 2. And now, is it commutative? Yeah. 1/2 times 4 over 1. That's the kind of stuff that we're going to be doing. Just running into problems and then seeing, how can I fix that? Because right now it's not commutative. Is there a trick or a way around that? Okay? So that's the kind of stuff that we'll refer to often. Are there any questions on that kind of stuff? Makes sense? Good? All right. Additive inverse. Additive inverse is when you have a negative 5 and a positive 5. When you add them together, what do they get? Do you know what multiplication? If I said what's the inverse of 4, do you know what the multiplication or the multiplication inverse of 4 is? What? 1. Because when you multiply, sorry, I can't hear you. When you multiply, you want the inverse. It's going to equal to 1. When you're talking about adding, you're going to try to get them to get to 0. See the little difference there? When you add, you want them to get it to 0. You multiply, they should get you to 1. Now here's the other weird part. Watch how this switches. This thing is called the Additive Identity. What? This is really fun. And I wish I had my other wallet. So I'll bring it. But here's my ID. Yes, he's got long hair. Whoa. Yes. I used to dye it blonde, and I look like a surfer. And then my one from college, it's about 2 or 3 inches longer. It's really long and really fluffy. And I used to surf, and then my wife decided to have a baby. I don't know why she did that. And then I kind of had to give up surfing. it was close toss-up. I was like, give up the kid or give up the second. But obviously I chose the kid. So anyways, why, when a cop knocks on my window and goes, "Sir, I need to see your ID," what does he want to know? He wants to know who I am, right? Right? He's going to take that ID, he's going to look me up, he wants to see, who are you? And my identification tells you who I am. What does the additive identity tell 5 who it is? When you add 5 to 0, what do you get back? Because 0 tells 5, guess what? You're 5. Okay? What would be the multiplication version of that? If I want a number and I wanted to say, hey, who am I? I multiply myself by 1, and I would tell myself, okay, good, I'm still 5. Okay? So that's what that ID is. That's why we call it identification. It tells them who they are. Alright, so let's look at this one. What would happen if I have a linear? J of x is linear, right? H of x is linear, but what is h of x? It's horizontal, which means it's going to be constant, right? What's my y value every time on this line? So what am I going to be essentially adding to j of x? Do you see I'm going to be adding 3 to it each time? So what's going to happen to this value right here? If I want to add these two together, what's going to happen to this value? It's going to go up 3, right? So he's saying it's going to be a 2 because you're going to go 1, 2, 3. What happens if I go to this value? What am I going to do? Just add 3, which means I'm going to go up 3. 1, 2, 3. And so boom, I would have a line that would be parallel to this other line because I've added a constant to it. I've just shifted the line up 3. Now what if I subtracted j, I took j and I minus h from it? It would just go down 3. So instead of being going up, I would go 1, 2, 3, and boom, it's right there. Pick another one, 1, 2, 3, and it would go there. And then my line would look something like that. Does that make sense when we were talking about a horizontal line and adding it to another line, how it would be constant because you're adding 3 every time? Yes? So what would you do if you were subtracting? Does the order matter here? Yes, the order is going to matter. So like when I do this, I have to make sure that I put my S value first, then take away the V value, because it will get me somewhere completely different if I do the opposite. So when I do this, what's the value? Let's go to 1. What's the value here? 3. So everybody see that that is 3. What's the value here? 1, and 3 minus 1 is? So what's going to happen? Where do you predict this line is going to be? And it's going to be what? Parallel to it, because 2 minus 0, watch what happens. 2 minus 0 is what? Uh-oh, for prediction, wrong? What happens when you have this one right here, which is what? Be careful on this one. Watch. Try negative 2. Try, we'll call, oh, they call it m of x. So try m at negative 2. What do you get? What's the s? What's f? S at negative 2. What's the value of that? S of x, when it's at that, it's at 0. Does everybody understand that? And I'm going to subtract. What is v at negative 2? V at negative 2 is negative 2. So I plug in here a negative 2. What happens when I have a negative and a negative? What does it become? A positive, and it becomes a 2. What are you noticing right here? It's a horizontal line. So when you take two lines that are parallel and you subtract the lower one, you get that horizontal line. Does that make sense? Because what happened when we added a horizontal line with a line like this? What did we create? A parallel line that was like this. So what happens when we subtract to do the opposite? You're going to end up back with the horizontal line, right? That's how it works. Yes. This is just, we're just talking about, don't try to fly too much from this. You'll be okay. Like, we're not going to see too much of this later on. We're just talking about functions, understanding how it can add them together and stuff, but we won't have too much to do. You'll be okay. You won't have to be like, oh, I see these two, and you're going to have to draw it right away. That's what I mean. You'll be okay. All right. This book always has like the try to figure out what's wrong. Notice this one right here. You have a line, and you are you're adding a parabola. Okay, you're adding a parabola. Well, let's look at this. Let's just make something up, because it's easier to kind of understand. Let's make something up like this. What if I had a 3x squared minus 7x plus 10. That's my parabola equation. Does everybody understand that? And I'm adding a linear one. What, can someone give me an example of a linear equation? So give me one. Okay, x plus 2. How do we know that that's linear? So this is the linear part. This is the parabola part. X is to the first power, right? Well, this is a parabola. When I add a line to it, this would become 3x squared. This would become minus 6x and plus 12, correct? What do you notice about this shape? It still stayed a what? Still stayed to be a parabola. How do we know that? Because x is still only squared. Does that make sense? So if you look at this example that they gave us, you see that you have a line. You have a line, and you are adding it to a parabola. And you still got a parabola out. The red is the parabola that they would get. And if you look at 1, what's my output for on the parabola? 1. What's the output on here? Negative 1. 1 plus a negative 1 is 0. 1 plus negative 1 is 0, which is why that point is right there. Does that make sense? How about a negative 1? What's the output here on this parabola? 1. What's the output on the line? I'm at negative 1. Looks like negative 3, yes? You with me?
Yes.
What is a 1 plus a negative 3? Negative 2. Do you see how that's right on that red line right there? Okay? So you can still do this even if it looks like a parabola, it looks scary. It's not. You're still doing the same process. You're still taking the y's and doing what with them? Adding them. Now watch what happens here though. Hope you're not getting dizzy. Watch what happened here. What do you notice? We had two lines and what they make. Why? What are they doing now down here? They're multiplying. So let's look at that again. We're going to make up examples. Let's say we have a line, x minus 2. Is that a line? Yes. And what were we supposed to do? Multiply it by another line. What happens when I multiply this? I get x times x becomes what?
X squared.
Which is, what do I know right away? It's going to change its shape and it's going to become a parabola. Do you guys see how this is working out? Kind of why it's working. Now again, all you have to do is if you're on this thing right here, you would take so we would go over to, let's go over to like 4. Where x is 4. What's the y value on this one? What's the y value in this one? Negative 1. What's the y value here? And negative 1 times negative 4 is a positive 4. Do you see how on the red, which is my new one, if I go over to negative 4, where did they go? Up to 4. Up to 4. Are you with me on how they still do the same thing. All they're doing now is instead of taking the y's and adding them, they're taking the y's and multiplying them. With this case, does order matter? No, why? Because multiplication is what? Commutative. If I was dividing them, would it matter? Yes, because order matters for that. What do we think?